here. Hello. So this is 3D printing and laser cutting. Some of you couldn't make it to class, which is fine. That's why the video is rolling as of now. I'm planning, and who knows what's going to happen, 2 videos. So one is laser cutting and see 2 options within laser cutting. Another one is 3D printing. Okay, so before you go ahead and, go through the videos, those in class already have done it, but if you're kind of new to this, you need to go to assignment 1 of phase 2, all the way to the bottom. There's a link. Actually, 3 links are important, maybe for you guys to look at it. You can open the 3 of them, but the bottom one is basically a way to download for free a software, which is called Ultimaker Cura. Who knows? Cura, I will say. I don't know how you would say it. It looks like this once you install it. You might have 1 or 2 little problems when installing it, but they're easy to solve. Maybe one of the problems is you download it, takes a little bit of time, is you need to create an account, number 1. Number 2, I'm not saying it for you guys. Number 2, an important thing is what was it? I lost my train of thought. It's basically after you create an account, you need to make sure you click on an option that is on the left side of the Windows, which says add a local printer, okay, not an online printer, a local printer. And what you're going to do is select a specific printer that we can find here in one of the other links from the assignment. If you go to actually this link, which is 3D printing info, you will be able to see this page. And if you're interested, and that already goes for you, you can take a look at how, it's described the 3D printing machines. There's a little bit of a history of how the 3D printing worked, and, the process of how we can go about it, the machines. And it tells you already that the ones that we have, there are other ones that are a bit more specific. The ones we have, that there are numerous of them, it's like the Ultimaker 2 Plus. Okay, so that's the one you have to search when you create an account in the Cura program and add local printer. You need to click on the Ultimaker 2 Plus. What that's going to give you after you're done through the process of account and downloading the software is something like this, that you can just orbitate with the right button. You can zoom in and out. You can add more printers here, add printers, and you can choose the local options. Here's to set the material, PLA. I would recommend you don't change those things. And these are mostly for settings that we can talk a little bit about right after, okay? Notice that there's a blue box here. This is the container I talked about last class. You can't 3D print something bigger than that. If you need to 3D print something bigger than that, what you would do is 3D print it in parts. That you can do with no problem. How big is that? If you go to the web page, it tells you that the volume, it's this one, okay? Now it's in millimeters, so you just can do a little conversion. You go to Google, say millimeters to inches, and that's the box you need to make sure things don't step out of the boundary, okay? We can do it right after. Okay, so the question is, okay, so I have a number of projects, and I wonder which ones should I 3D print, which ones are laser cut. So I'm just going to do a very simple laser cutting of this proposal. Who wants to open? Great. Or pause here. Yeah, after it opens, so this is a project that probably makes more sense to laser cut because of its planar condition. You can also 3D print it, but you have to slowly start understanding what proposals makes more sense to laser cut and which ones to 3D print. In general, if there's a lot of planar surfaces, like in this one, probably the answer laser cutting is going to be better. Now, it's true that 3D printing, if it's more affordable, maybe you want to go that way. But if you're going to large scale 3D print, it's going to be like a little bit of a nightmare because you're going to have to do multiple pieces and so on. So it would probably make more sense if large scale models to laser cut the shell and then introduce smaller 3D printing components. Okay, so this one I'm going to laser cut, and I'm going to talk about two main strategies for laser cutting. Okay, so one of them is let's call it the full body of it. I wanted to laser cut it. What you can do is use the command contour. It's not here actually. If you use the contour command, contour allows you to create multiple sections and decide what is the distance between each of the sections. The first thing that Rhino says is select the objects for contour. So you can select the object or objects. You can press enter when done, and then it tells you, well, what is the base plane? You typically select the bottom, and you click a second time in the direction of the perpendicular planes of the cut. You'll understand once I finish this. So I'm clicking once there, second time here, and it's going to ask you an important question is, well, what is the distance between each of the cuts? So just to understand this, the 1 feet, if I press enter, it creates this number of cuts that I can move afterwards outwards. Okay, so I don't know if you can tell, but these are individual plans. It's almost like applying the section command multiple times and having a parameter of what is the distance between each of those cuts. That's the contour. So how can we use it for laser cutting? Well, if we know the thickness of our material, okay, we can say, well, give me a number of cuts in this direction, distant the thickness of my material, and then you send this to the laser cutting. It cuts it and you glue one on top of another. Okay, I'll explain the process of laser cutting, preparing a file for laser cutting, but and probably that needs to be said. I'm going to separate each of those cuts. The best way to understand things is by doing this. So I'm going to do this very fast. You might not be able to tell because I'm in the front view, but what I'm doing is separating each of the, let's call them section plans. No? For those in the video, maybe you shouldn't lose the time doing this. This is more to understand the whole idea of contour. Why? Because we haven't done one big and important step before this, which is thinking about how big the laser cutting is. So if you think about it, I never actually scaled down my entire volume, and the entire volume of my Rhino model is 1:1. So it's actually it's a building. I'm not going to be able to laser cut my building at real scale. So we're going to have to do the first move is think about how big the model should be, and then do the contour with a specific thickness. But this is just to illustrate how contour works and how can we work the result of it. Okay, this is a number of plans, as you can see, and I just distance them a little bit. And notice that they have a vertical dimension for obvious reasons. I was just moving them horizontally, but there's a command. I go to the perspective and I say project to C plane. I'm sure you'll remember that the C-plane is the grid plane of Rhino. So the command project to C-plane is exactly what it sounds like. It's just to send all those cuts and place them in the, let's call them floor of Rhino, the C-plane. It will ask you, well, do you want to delete this? Yes or no. If I say no, you will keep the ones above and it will project also. If I say yes, it will delete the ones above. I'm going to say yes and look at the, let's see, the front view probably, or even the right view. When I say yes, it's just going to smash all of those together downwards. No, this is a great tool later on. The project to C-plane. Why projecting to C-plane is important is that we're going to prepare those drawings inside of a rectangle. And it's good that they're actually in the floor of Rhino. So the next step, if this was the correct scale, would be, well, let's move them here. And let's say, well, this one gonna be right there. This one's gonna be over here. So you're gonna gather them all together in a nice, organized way. No? And those, and I'm just gonna do it very fast, should be inside a rectangle. And I'm gonna tell you in a second how big it should be. That rectangle, it's gonna define or symbolize the size of the bed, the cutting bed of the machine, of the laser cutting, no? As you can imagine, this laser is like a little machine that goes around cutting stuff, cannot take a walk outside of the room and invade the earth, no? So it's gonna have to spend its time in a specific XY dimension, okay? So anyway, that's a little bit the process from contour to that rectangle. But let's think about scale a little bit. What I would do is do it like a bounding box. It's a great command that allows you to see by pressing enter a couple times to see the box that contains all of the things that you select. So that's a great way to say, well, I'm going to place, if I go to the drafting tools, a couple of dimensions. So I'm going to say, well, I want to know the X and Y. So that's 28. That's 31. And if I go to the front view, I'm going to do a vertical one here. So that's 16. Now, obviously, these are feet, so that's just not going to work. We need to make sure that this is the adequate scale. No? To scale this properly, you can do it in two different ways. Scale is the command you should use, of course, and not 1D nor 2D. 1D is stretching and 2D stretching only one direction, not in two. And scale is the one that proportionally scales things in all directions. So what I would do is select the entire thing. I will place the origin point in the 0, 0. And then here's where you do a little bit of math. Okay, if you want a specific scale, you need to start, you don't need to do the two clicking, you're gonna set a number, 0.005, whatever the fractional dimension you need to get the scale adequate. So if you do that, it's going to be like a really small thing. Depending again on what scale you're dealing with. But you could also do what I say the manual scale. It's scale, origin point, and then you say, well, this dimension I want it to be, let's say 1 foot, for example. Okay. So this is to scale down and think about, number one, the scale of the physical model. It's not going to be obviously the real scale 1-to-1. That doesn't make any sense. That's called constructing a building. It's going to be a proportion. So if you're dealing with a specific scale, you need the fractional number, scale, origin point, introduce that fraction number, and you will get the actual size of the thing you want to make. That's number one. Another option is manually. You know that there's a maximum size that you want to accommodate. You can say scale from origin point, this dimension, first click is this one, second click. All of those relate to the scale command, okay? So once you figure out your scale, and now this is to be scaled, you need to scale it. Now you can do the same process of the contour. No? If it's planned, I'm going to do it again. You will select the model. You will say contour. You say base point. I'm going to do plans in this case as well. So I'm going to click once and twice as a direction setting for the perpendicular plane to happen. And obviously the distance between contours cannot be 1 feet, because 1 foot is going to be huge, no? So this is the moment where we know the material thickness. You know, if it's a 1/4 of an inch, for example, you will include it here. If it's a 1/8, if it's a 1, whatever. No? So you will press enter and you will get your cuts. Okay. I'm going to do the same, but with a bigger thickness because I don't have the time to organize everything. And I'll just repeat contour, select. In this case, I'm going to do sections instead of plans. And I'm just going to show you that if I click on the 0, 0 and I go instead in this direction and I click 1/8 of an inch, sorry, 1/2 of an inch. So this is just obviously it's very big as a material and you can't deal with that thickness, but I'm just going to do it this way so I can actually prepare the files a little bit faster. But notice what happens if I signal this direction instead of the opposite. If I click enter, I get those sections, vertical sections instead of horizontal ones. Okay, so each of those represents a section, and the distance between each of those represents the thickness of the material. Okay, so now whether it's this one or whether it's plan, I can think of how this generates a model. It's more of a map model, but you could also imagine this having inner guts and having, you know, space inside and still do the laser cutting this way, and it will work perfectly. Okay, so now we have some contours. You're gonna have to go back and forth, thinking about thickness, thinking about how big the scale is, et cetera, et cetera. The question is, how big is the bed of our laser cutting machine? So here's a little information. This is the other link that you can find on Canvas, and it's a little bit of the basics of laser cutting. And I think it's very good to know about these things. Notice that there's a little piece of wood here, and then there's raster engrave, vector score, and vector cut. We're not, I mean, I don't recommend using much of the raster engrave. This is a bit of, you should have a, I mean, you might want to use it. Let's explain all of them. If you have a vector that's in Illustrator, Rhino, or AutoCAD, regardless of the program, it should be vector-based, okay? If you have a fill of a text or of a symbol or of a wall, if you want to engrave it, this is the way you will do it. You will do black fill, no stroke, RGB000. That means black fill. Does that make sense? So that we're thinking a bit of Illustrator in that sense. If you follow these 3 parameters, like the black fill, no stroke, you will get this result, which is basically like shaving, engraving the whole inner surface of that vector. No? If you want to only engrave the vector, so you're scoring the perimeter, you're going to do a no fill, but you're going to do a 0.1 point stroke in blue. That's 00255. Okay, and that's going to create that effect, which is, why not? For example, you might want to engrave some windows instead of cutting the window. You might want to engrave some pattern on a floor instead of cutting it through. And then obviously the most important is the cut, no? And that's a vector cut. You say no fill, red 0.1 stroke. Now, I have to say the most important being the color. The machine, what looks is as red and cut. And I think the thickness is not a big difference. Just follow the 0.1 point, but it's going to do pretty much the same um, cut regardless. But if we do the 0.1, that would be ideal. Okay, R25500. So if we have this in mind, I think we kind of know how to talk to the machine. We're just missing one important thing, and that's the size of the bed. So as you can imagine, we're going to find it somewhere here. There it is. 18 inches by 32. That's the bed. So I would recommend we go to Rhino, we go to the top view, and we do a rectangle command, and then you start whatever for now, and then you just include those two numbers. So it's 18 inches, 32 inches. Okay. So I would do this actually before anything else. I'm rotating this 90 degrees. Because it's already telling us a lot about how big our model should be, no? If I take one of these plants, for example, move it around here and put it there and project to C plane and say, yes, delete that one. I can do one plan, maybe another one. It doesn't sound like the ideal scenario for this math model. I've seen students doing relatively detailed projects at specific large scales, and they typically need 3, 4, maybe maximum 5 boards. Okay, but not like 20 boards. And I think ideally, if you're in the less than 3 boards, better. Okay, what does it mean board? If this is the bed of the machine, you can place a material board. Is the board the same size as the machine bed? Well, most probably not. No, most probably you're gonna go to the shop and ask them, well, what do you have? And we have this and this. In what size does it come? And they might say, well, it comes in, 12 inches by 28. I don't know, whatever size. So what I recommend is that you always draw the rectangle of the bed, of the machine. I'm going to change the size to inches. So that's the size of the bed. Maybe you want to even do this before anything. Give it a nice red color. Have it there as, lock, and call it something like base, bed, laser cut machine. Okay. So every time you come about it, you want to have that. You can use that again and again, and making sure that's the one you're working with. Oftentimes, the people on the laser cutting will say, well, wait a minute, it's probably a good idea that you also leave a little bit of a space between the edge. So something like an offset. If you use a command offset, you say, I don't know, like a 1/4 of an inch, something like that. Maybe that's a bit too much, but that's gonna keep you a bit on the safe side, no? So you can call that something like safe area, and lock that one as well. So we have a safe area. You don't want to put anything outside of that safe area. Because, things move slightly. There's no such thing as perfection in any of these things. So, and what I would do is no matter where you put your cuts, I will put them inside of the safe area. But regardless, more important is that you need to put the actual size of your board. No? So if you want to be 100% sure, you would put a couple dimensions that will show us the size of that board. Okay. So, I mean, I did this one, probably doesn't make any sense, but let's just imagine that a 15 by 25, you go to the shop, and that's the one they're giving you. You can't put your cut there, no, obviously, because you're going to be placing every single cut element inside of the board, not of the safe area. You have to consider the material, of course, because that's what you're going to be cutting into. This is my material board. Okay, so that's a little how we need to structure things. We need to start then placing any set of polylines, curves. Ideally, they're close. Otherwise, you're going to cut whatever line and they're not going to be closing by. And you're going to place all of those in your material board. And if you need more, what you do is the following. You do this, copy the whole thing, eliminate this one, and add your next set of drawings there. No? Go to the top view, place the next one, and project to C plane. Yes, there you go. So as many boards as you need, that's how you will do it. Okay. Now, I think you can tell already that it's important the scale of the model decided in terms of how do you want to communicate the idea of your project, or what is it at stake, you know, how do you want to show this, etc. Those are more important than how big the panels are or whatever. But once you have decided that scale, you might need more boards, less boards, therefore more of this kind of a panel organizations, okay? Now, for this particular project, I will probably not make it so big. I will probably reduce the scale even to a smaller degree, and I will include every single curve. Okay, so that would be pretty much the massing option. I'm going to scale this a little bit smaller so you see the second option. The second option is not about the mass, not about the contour option. The second option is the following. What we're going to do is laser cut the shell of it. The shell is the exterior set of surfaces. So I'm going to just copy this one here, and I need to work out a little bit these elements. The first step I need to do is actually explode. Why do I explode these surfaces? Well, you'll see in a second why. If I explode these surfaces, I can start getting the different elements. The different surfaces that make up the project. Okay. And if I have these surfaces, there's a command that you can find here, which is here. It's called the duplicate borders option. And what does that do is basically dupe borders, enter, and it creates the polyline that it is the border of that surface. We cannot laser cut a surface. We need the perimeter line, which is the border of that surface. So that's where the duplicate the border, it's a fundamental tool for you to use. I'm gonna go back. So in that sense, and without almost continuing, you can kind of sense how this is gonna work. We need to duplicate the borders of every single surface. We need to then allocate them in each of the, you know, boards that we are going to be 3D laser cutting. No? So I'm just going to do some of them so you get the idea. I'm gonna, one thing you can go about is select all of them after exporting and say dupe borders. And I can even take them all out. Those are a bunch of polylines, and I can just start moving them maybe from the top view, being easier. And I'm going to start moving them on top. Notice that there's a three-dimensionality to it. Some of them are very obvious ways to move them into place. And remember that it might be a little tricky because some of the times it's like detached. So you need to select all of those and then move them into place. Those are easy to, oh, not so easy. That's a problem. Gonna move them here and here. Okay. But the other ones we need some rotating and some, obviously put them in place. Some rotations are very simple. Like the vertical ones, you can just go, for example, to the right view and do a rotation, which is, like clicking and clicking. You can do that from the right view, or a Control C there. You can just click on the rotation 90 degrees and it rotates it, and then you can just move it into place. Those are easy, 90 degrees rotation, no? I think it's straightforward. By the way, we haven't talked about it, but there's a very easy 3D rotation. It's called Rotate 3D. And what it does is that you can set an axis of rotation, and then you can rotate around that axis, which is a very cool tool to work on perspective if you don't want to jump into the front, right, or top elevation. So if I want to rotate this in this direction, the axis of rotation should be this one. And then up here. Okay. And you go with all of them. Some of them are straightforward. Other ones need a rotation of 90 degrees. Next, you also have sometimes and oftentimes a non 90 degrees rotation. It's just a bit more complicated, but it's not that difficult. We have this thing that from the top is an angle, and that could be also for, imagine, roofs that are tilted. How do we deal with those? Well, very simple. You can do two rotations, which is one here, here, ortho, and then 90 degrees. I don't think it was that difficult. Instead of one rotation, two rotations. No, one rotation, another one, and then move it to where it should be. Okay, and on and on and on until you get all of the elements. And here's where you might have gone through this process and say, well, professor, what are you going to say in a second? You should have said it earlier. Well, I am displacing each of those ingredients into the boards, no? But this model might be relatively easy, but imagine if it's a little more complicated, like you have 55 interior partitions in different angles or whatever. How do you remember which partition is what? Tricky. So that's where what we do is a little bit of going back, Control Z, the whole process. And what we need to do is still do the explode. We still need to do the duplicate border. Okay. And what I will do is allocate every single one by one, a bit more carefully, and adding from the top view, maybe even after it's being projected. On the top view, you can add a simple text. This is a text. It brings this little command, and you can set curves. If you want, you don't need surfaces or solids in this case. You just want a curve, and then you will say something like T1 top 1, or so a code that you know what is it about. No, you place that here. Obviously, the size of this should be much smaller. So let's actually do this 0.01. And Don't know what that is. Maybe it's too small. It's a little funky. I don't know why. You definitely want to do this smaller, something like this that doesn't really get rid of the grid. And you want to put it in a place that anticipates that it doesn't bother the model. No, you don't want to have this, I don't know, in the middle of the living room or in the middle of an important part of the model that you see T1. What is that, professor? In the final critic, it's clearly going to happen, that question. So you want to place it in an area that's going to be darkened, or you might want to flip them somehow and put it on the back. But you definitely need that code to to know that that particular code is the piece that is on the top. One thing that you can do is add annotations, which are very useful, which are on drafting and this annotate dot. These are fantastic elements that they're mostly three-dimensional annotations. You can say T1, for example, say OK, and you place it mapping to the surface. So that's no matter where you go, the T1 stays there, and you know, okay, T1 is that surface. I know T1 is the one engraved. No? Again, I wouldn't do all this if it's a model is ABC, but if it's a complex model, you need a little guidance into where goes what. Otherwise, you're going to be lost in the process. Okay. So if that's the case, then you will select one by one the pieces. You will project to C-plane. If you're inside of the safe zone, you're good to go. So you can put it almost practically on the edge. You could even say that your material board, it's allocated outside of the safe zone, and then you just use the safe zone for the line work. So you move it, you place it always in the green area here, no? Okay. Now, in terms of color, as we talked about, we do have a couple of points that we need to address. So is if we're scoring, maybe the T1 you want to score, you don't want to have it very engraved. You just add that into a particular layer. You can even call them as they have them here. You could just copy and paste here, vector scoring. You could say score and 0, 0, and then the blue, no, which is this guy, 25. So that's that. Right click, change of the layer, and that's the one. Now that's definitely cut, and cutting is 0.1 points vector only, and it's red color. So you will create another layer. You can say cut, put that over there, and 255 for the red. I did it here, but you can do it in Illustrator. You can just have 3 layers in Rhino. Don't worry about the color. You do, as we know, select and export to Illustrator. And then Illustrator, you change the colors if you want there. As long as you have the layers, you can select the layers very easily and change the color. But I happen to know that they do accept Rhino models, AutoCAD models, line drawings, actually they are, and Illustrator. As long as it's vector-based, they accept it, okay? So you keep adding things. I'm just gonna do one more for you to kind of see the process. I'm gonna choose that one. I'm gonna rotate 2 times. I'm gonna actually rotate 3D, so that's gonna be this axis. And in this case, I'm gonna do another text here for, let's say, side 1 or whatever it is. I should just make sure the scale is the correct one. A very small element should do it. And I'm going to move that from the top view to whatever position I need it to be. You can rotate these ones. It's as long as you don't mirror. Mirror is not obviously the same, but you can, with no problem, rotate. We place all of these little guys into the score and this one to the cut. You can do this changing of layers at the end and you should be good. Imagine you want to do the engrave. Well, you just fill this thing. So there's the hatch command. No, you do a hatch and then you can have different hatches. In this case, solid is the one that we're looking at. And, in theory, you will create another layer. You will call it engrave. Oops. And add it here. Okay. So that would be the difference. I will be consistent. I wouldn't engrave all of them or some of them and other ones. I think this is less aggressive. Also, this takes more time on the machine. So you might want to go with this, unless you're doing a very nice title. Imagine you do a base board where the model is going to be on top and you want to do a title of design, whatever, my name and the professor's name, and you might want to do that engraved. But, otherwise for marking, I don't think it's necessary. And you go on. Notice that I am rotating some pieces and I'm not really touching because that's not a great idea, but you want to be within the safe zone and close to the neighbors in almost like in a bit of a distance, because what it does, the laser is burn, burn through it. So you don't want the quality of the burn on the neighboring pieces, So you just want to make sure you leave a little bit of space, maybe a quarter of an inch is enough, or just by eye. But you do want to take advantage of and economize the space of the board as much as possible, because it's logical to do that. Okay. So once you're done with this, you need to send this to the laser cutting machine. Ideally, I think that's the way. I don't know if they accept online submissions, but ideally you go with a pen drive and you leave it with your board. It's like a pen drive and board. But I think you can send them an email as well, and that will be all explained in the web page here. And I will also add not comments here. You can add a text and send and write some comments on the side in the text, or you can do a dot and write some comments, like something like secondary text, and here is like please read, and you do something like that, and then you say this I have placed 4 boards. The material I want is this one. Please revise this or that. Take care of my files, please, or whatever you want to say. They read these things, so just make sure you have a couple comments if you need to make sure of some things. Okay? They definitely don't need the dimensions. It's for you, but you can leave them there. They understand that those are part of maybe these ones you don't need. Okay, another thing that they typically don't like the machines is that you have 2 things on the same place. So if I copy this and by accident there's 2 of these on the same place, you can't tell the difference because they're in the same place, but the machine understands there are 2 lines there. So it's going to go and cut once and cut twice. What does this mean? If you cut once, the piece gets loose, obviously, because it's like detaches from the main board. And what's going to happen is going to cut through it again, but the piece might have moved a little bit and rotated a little bit, and it's going to cut through the whole thing. So just be careful that you don't have 2 things on the same plate. I think you can detect double. I don't know if there's a command, but I can look at this carefully and remind you later on what is that command. I think it's in Rhino, in AutoCAD is kill the duplicates or duplicate. Let me see. Extract duplicate mesh faces or the player. Anyway, I'll let you know. I know there's a way that you can. Oh, I know. The only way is actually doing a make to D. It sounds weird, but you do a make to D of the drawings, and what it does is eliminate those 2. I would just probably be careful in the process and start selecting the different drawings. And if that pops up too, you know there are two things on the same plate, and that's when you select one of the two and you delete. So try to avoid duplicated. That's true. The make to is what eliminates the duplicated. In AutoCAD, you have the kill duplicate, and I think Illustrator, you're going to have to go one by one as well, being careful with that. Okay, so that's what you send. What they're going to do is put the results of it into a shelf system, and you can go and pick them up whenever you want. You definitely need to take the material with you. And if you're wondering what materials are accepted, well, the size and scale here, explaining the size of the panel, but there's the materials that are acceptable: wood, paper, acrylic, etc., etc. So a lot of materials, they only do not accept some materials that are toxic, but if they have them in the stores here, it probably works. As you can see, we can cut up to a half an inch material in most cases. So for thicker materials, you should plan a test cut first. So half an inch is crazy thick. I don't think any of you are going to go in that direction. Okay. Last, just as for your information, is well, there's an issue of how thick the material is and how does it meet the neighboring piece when there's an L-shape connection, or surface to surface L-shape are touching two of them. No? So think that the thickness of one of them and the other one is going to force you to make a decision. It's like really one against the other one, and this one I see the edge. If that's the case, if it's a very thick material, you're going to have to do an offset of the curve in one of the directions, because otherwise you're adding to the exact dimension of the model. Does that make sense? So you're going to have to plan ahead and do that kind of a shift and offset of the different line work because of the thickness. Okay. There are ways to do also this connection. So basically that you do a castle shape connection for one of the pieces, and in the same castle shape but shift in the other direction so they match perfectly. I don't know if that makes sense what I'm saying. So to do that, you need to do a little bit of work here. You probably need to do an offset surface. You're going to do flip all. It goes in the direction. You're going to say, well, what is the thickness of that offset? Let's say 1/8 of an inch, just to do, and enter. Look what happens. It goes in that interior, and I'm going to do the same, flip all here. So this is the situation that you have one and another one meeting in the same place. If you want to be very precise about the dimensions of your project, you can't just say, oh, I laser cut perfectly those, and I just glue them one next to the other one. If you do that, the glue is going to be on the side, and you just automatically distorted the proportions of the project. So if you want to be precise, there are two options. One, you actually do something like a Boolean difference. This one enter, this one out, and it eliminates that chunk. So then the other piece comes exactly in place. I don't know if that makes sense. So you're going to have to do a little bit of, from where I eliminate, which ones, do I want to see an edge here, et cetera, et cetera. Those are a bunch of questions. Another option could be, if you want to do that castle shape or like a shifting condition, that you can do a box and you say, well, I'm going to do this box here. I'm going to copy it and go all around the model. I'm going to do a Boolean difference between this one and one yes, one no. And then the same Boolean difference Wait, did I lose the? Here, there. So that will be up and down, and the other one has to be the inverse, no? So Boolean difference, enter. Where is it? Okay, let me hide this. Boolean difference. Okay. So, and now this is probably a perfect, well, not perfect, but at least you don't have to kind of offset the top one. You have both of them in the same dimension, and they just connect nicely and naturally um, in the corner, no? Now that might be easy here and all of the straight lines, but it might be a little more complicated here, but it's just an issue of working out. These details typically show that you master the fabrication process, which is a bit more of an advanced process, but I think it's a very powerful one to show. Okay, obviously once you do that, what you would do is explode, select this one, and duplicate border. Something happened here. Oh, why is doing this thing? But you get the idea what it should be. You know, when I say duplicate border, for whatever reason, it does a weird shape here, but it should obviously give me or give us a whole set of shapes, and that would be what we would place here instead. No, does that make sense? I think might be an issue of the version that I'm working on, but you need to bring that drawing into the bed of the laser cutting. Okay. Okay, so let me stop that.